Yeah.
Yes.
Yeah, it's usable.
Okay. Okay, so let them start. Yeah, and yeah, first of all, I would like to align on the topic that we are going to discuss today. The topic will be databases. Yeah, especially yeah, the SQL databases. So what is the SQL database? Yeah, it's a relational database. So in general, we have two let's say types of databases. Yeah, it's the relational and non-relational. So basically SQL database and no SQL database. Yeah, and the SQL database is just a set of tables, yeah, that store a specific set of structured data, yeah, which is aggregated and managed with a specific language, yeah, called the SQL. So basically, yeah, the structured query language. And as you can see here, we have different examples of the SQL databases. It's the Microsoft SQL Server, MySQL, and also PostgreSQL. So let's then move to the agenda. Yeah. So what we are going to learn. So we will start with the let's say basics. Yeah. We will talk about SQL operators and the types of the SQL operators. Yeah, we will touch base on the triggers, aggregation and grouping in the queries. Yeah, the relationships, the relations that you can establish within the tables in SQL databases. So basically, how you can establish them, yeah, using the primary keys and foreign keys. We will also take a look at the joins. Yes, how you can, let's say, combine two tables in a single query. Yeah. Then we will also take a look at the views, the database normalization. So yeah, we will also take a look at some kind of optimizations, yeah, like indexes. Then we will like talk. I think that's the important part about the migrations. So really a lot of projects in all over the world, yeah, using the migrations to somehow like manipulate with the data that's already exist or should be migrated, yeah, to the database. Also, we will I will provide you with examples of the attacks that could be focused on the database, yeah, especially the SQL injections. And after that, we will take a look at the ORM. Yeah, it's a it's a pattern. Yeah, and we will take a look at the packages that are working with that kind of pattern. And yeah, we will provide you with some examples of how you can work with them. Yeah. So, yeah. Let's move to the SQL operators. Yeah. So here we have a list of operators types. Yeah, that we could have. It's the data definition language, data manipulation language, transaction control language, and also data control language. So we will dive into the details about each of them. Yeah. And yeah, so let's start with the data definition language. So these comments are basically related to the some meta things, yeah, like let's say defining the database, defining the table or some kind of a view, yeah. And as you can see here, we have two comments. Yeah, the first comment is basically creating the database, yeah. And the second comment is creating the table. And for the table, as you can see, there is a specific name of the table called person, yeah. And also the fields, the description of the fields that exist in the database. So we have 3 fields. One is ID field. It has an integer type. It cannot have the null value there. Yeah, and this is the primary key of this table. And 2 additional columns called last name and first name, and their type is the string. But that's how we can specify the maximum length of this kind of string in the database. Yeah, and also, in addition to the comment that we've just discussed, yeah, you can also create tables, and also you can drop the database table and view. So basically remove them. Yeah, the command is pretty simple. You're just for the database, you're saying that drop database, something like that. Yeah, and drop table and just the table name. Yeah. Also, you can alter your table. So let's say the situation that in project you have a user and your customer asks you to add some kind of additional info. Let's say it will be the phone number. Yeah. So when to store that data in the database, you would like to extend your existing table with some additional columns, or for example, drop some column. Yeah. So you are writing the query like alter table, then providing the name, and then additional, let's say, comments that are related to the way how you would like to adjust. Yeah. So in our case, in the first example, we've adding new column. Yeah. And in the second example, we are deleting column from the table. Yeah, but it could be also the rename of the column. For example, you can also change the type and yeah, the let's say parameters that are tied to a specific column. And moving to the next type, yeah, it's the most used. Yeah, it's the data manipulation language. So such commands are related to the getting the data, updating the data, modifying, yeah, and also deleting data from the database. Yeah. So in that example, we have a query that is actually responsible to get the data from some table. Yeah. So you can, with this kind of sign, yeah, you can specify that this query will get all the columns from the table, but you can also specify which specific columns you should get from the database. Yeah. So as you can see in the second example, we are saying that, oh, please get the first name and last name from some kind of table. Yeah, in our case, it's a person table. And there is an additional statement where we specify the, let's say, which and filter out some data. So let's say we would like to get all the records with the first name equals to John. Yeah. Yeah. In addition to the getting the data, we can also insert the data. Yeah. And the way how we can insert it is basically insert into, yeah, then the table name. Then you are just providing all columns, yeah, that you would like to insert. Some of them might have the default value, yeah, but and after the in the values, yeah, you can specify which values you should actually insert into that table. Also, yeah, the updating, the update is, yes, let's say straightforward. Yeah, you are providing the command called update, then you are providing the table name, and then you are specifying the fields that you would like to update. So the first one is just a name of column. Yeah, so it could be the first name, then equals to some kind of value. For example, you change your last name from one to another. Yeah. And also you can add the condition. Yeah. So you can specify it for a specific user ID, or let's say after some global change, you invented a new field and you need to update all records, let's say with some kind of status equals 1, to, I don't know, maybe 3, or set them some kind of additional data. So everything could be handled within the update operations. Yeah. And the delete, actually the same pattern, but the start of the query is a little bit different. So you're basically delete from some table, and also you can specify some kind of condition here. So in our example, we delete the person from person table. Yeah, that's have ID equals to 4. Yeah. So that's all operations that we can do with the data manipulation language. Yeah. And let's then move to the transactions. So for the transactions, we also have a specific, let's say the bunch of operations and commands, in the SQL that are related to for handling the transactions. And what is the transaction? So transaction is a group of, let's say, several queries, that are grouped in a specific let's say unit, and it's follow the logic. If it fails, it reverts all the changes that were triggered within that unit. So it's really helpful in the application in case of some kind of unexpected errors, or let's say expected errors in our application. So during some kind of update, we are doing the update, updating some data, and then in some kind of, I don't know, there is a bug, in our application, so something is wrong, and to make the data in the database like clear, and up to date. We don't want to do the update that we did before that kind of error. So that's how we can approach that within that transaction. So we wrap all, like, let's say, the entire logic of the endpoint into the transaction, and that's how we can avoid this kind of data like lags, or avoid the incorrect data in our database. So moving to the commands, the command is begin transaction to actually start the transaction, to the commit to end the transaction. Also, you can set that transaction to a specific like ID, and basically roll back the transaction. So how it looks like? It looks like here, like this. So we are starting the transaction. The database automatically will like create some kind of unique ID, but you can also, as I remember, specify the ID for the transaction. And basically you are putting some kind of code. I mean the SQL code here. So as you can see, we are inserting a new record in the user table, and then getting it from the user. And let's say on the step when we are getting the user, for some reason it errors out. Yeah. So and if it's handled in the transaction, that transaction will automatically will be rolled back, and the changes that we did within the first comment will be rolled back, and there will be no such record in the database. Yeah. And you can also specify the commit at the end of the transaction. Yeah, and a thing that I would like to point you out, yeah, in real applications, you don't need to do that kind of transaction handling by yourself. Yeah, it's automatically handled by some tools. Yeah, some packages. Yeah, they're automatically providing some kind of API where you can just, in the code specify that this is the start of the transaction, and you are just executing code in that transaction, and it will handle automatically. So basically, I just provided the example how it actually works under the hood, yeah, in their database.
I have a question about rollbacks.
Yeah.
So as I understood, and maybe I understood good, when we use rollback, it's just technically saves this data, for example, as a backup in some dump database. And can we just see this backup or dump database visually, or?
Not sure. As I remember, in some database, there is a specific, let's say, I do not remember the specific name of that, but let's say the list of oh yeah, just a second. Yeah, the list of the comments that were executed, and I mean the logs in the database. Yeah, and I think that yeah, in that case, we can see that. Yeah, basically you will see that there is some kind of insert here. Yeah, and after that insert, you have the rollback of the transaction. Yeah, so I guess that's how we could see, but I do not think that specifically in the database, yes, there is like some kind of table or specific field of data where we store that kind of thing, because imagine storing the entire database for each insert, it will take a lot of memory there. Yeah. So I think it could be handled on the local level, not on the some kind of dump or the copy of the database.
Oh yeah, thanks.
Mm-hmm.
Can I ask you a question?
Mm-hmm.
Okay, and are in SQL database table names case sensitive?
In some, as I remember, in some database it's case sensitive. In some it's doesn't matter. Yeah, and even that it could be supported by the engine. I mean, there are different varieties of engines. Yeah, of the databases. For the MySQL, you have as I remember, AWS has its own engine called Aurora, something like that. So it could support, but in some cases it's case sensitive, in some cases it's case insensitive. Yeah.
And the same applies with column names, right? Some are case sensitive, some are in case insensitive, right? Column names.
Yes, and also the names of the tables. Yeah.
Okay, thanks.
Mm-hmm. Okay, then let's move on. Yeah, and basically, yeah. So the last type of comments that we can use is the data control language. Yeah, so it's so to work with the database, yeah, you should have a specific user, and you can provide some kind of let's say, privileges, to that user. So let's say we have a root user with some kind of password, the admin, and I would like to provide for one of my colleagues, the specific user with a specific privileges, and let's say I want him to have only read-only mode, so he cannot insert anything in the database directly. He can just get the data and see trigger some kind of queries. So that could be done with that kind of comments. As you can see, the grant is actually adding the privileges to the user, and revoke, it just revokes the privileges from the user. And as you can see here, we can the way how we can create the user, and basically the next things are granting some kind of privileges. Here we are granting all the privileges on a specific database for a specific user that we created. So that's how it works. It's let's say from the development perspective, it's really a rare case. When you are doing that kind of things by yourselves, it's like in the major cases, it's done by the DevOps or some kind of other engineers. And I can see the question. So should I name user table or the users table, the user or the users? Certificate. As I remember, it depends. But in our application, we are using just a user. User, some kind of, I don't know, certificate, like let's say exam. So, but it depends. It's you can also argue with other people, but there is no like big thing behind that. It's just a way how you are structuring the data. Okay. So
as I remember, MongoDB has actually automatical plural conversion. For example, if you write user, it converts to plural and writes users.
Yeah, that's interesting. But in the SQL databases, you definitely do not have that thing. Yeah, but good to know. Okay, and we will also talk about the triggers. So what is the trigger? It's a specific query that you would like to execute after some kind of event. So let's say you have a table called, I don't know, user. And additionally, you have some kind of internal columns that are responsible for tracking some metadata. So let's imagine the basic situation where we have the user and we would like to track who updated that kind of row and when updated that row. So it's like the updated profile ID or something like that, and updated at, and you can handle that within the trigger, to like, I'm not sure that you can handle the updated by, but updated at, you definitely could handle within the trigger. So you are creating the trigger specifying when it should be executed, before or after the event, on which table, and then inside the begin and end, between the begin and end, you are specifying the trigger logic. Let's say the simplest example, if you create, I don't know, additional row, or additional row in some specific table, you would like to increment some number, in another table. So that could be handled by the triggers, because let's say you have the big application. There are a lot of places where we update or create the record, And we can specify the trigger on the database level, and this kind of thing is going to work for the entire application. Yeah, but you should be careful with triggers, because triggers are not, let's say, easy to understand. They are a hide from the like general logic. So basically, if you like open the code, you will see that oh, there's like just an insert, but under the hood there will be actually the logic that will update some kind of value in another table. So you should be like careful with the triggers and make sure that in your application it's clear that triggers exist, and you should like put some notes, or especially in the maybe in the database servers, do that, like provide the list of triggers, yeah, or implement them within the migrations. And so yeah, after that we'll talk about the aggregations. So that's how you can aggregate the data. So basically you are getting the data, but you can also do some additional things, like let's say, so distinct, yeah, it returns a unique value. So if you have let's say 2 Johns, yeah, you can like return only 1 John. Yeah, you can use distinct. Yeah, so let's say you have the table, and you would like to get all unique names from that table. Yeah, you can use distinct. So on some kind of field, yeah, or column. Yeah, you can also calculate the sum of some field. Yeah, the average. Also the count, if you need to, the general way of using, like count rows in the database, how many rows we have, yeah, or return the minimum or maximum value from the table. Yeah. And in addition to the aggregations, we can also combine it with the group by. So in some cases, you would like to group some values in your table. And the general use case for that is, let's say you have the user. Each user have the, let's say, first name and the other information. And you would like to get all distinct users, yeah, by the first name, and provide the count of that users, or like other things that you can group by, yeah. But basically the group by just groups rows, yeah, and just provide a single value instead of this group. And as I remember, it will be the first value, but under the hood you can, within the additional comments, you can somehow manipulate with that data. Yeah, so you can just, I don't know, lint all the last names in a single row, or calculate the count, or the sum, some kind of salary. Yeah, something like that. And basically, yeah, we've talked about the tables and how we can do stuff with the tables and the data inside the tables, but it's not only about one table. It's more, the database is more about the set of tables. Yeah, and basically such tables could have the relations. Yeah. So the general like types of relations here are listed, and it's one-to-one, one-to-many, and many-to-many. We do not mention many-to-one because it's reverse of the one-to-many. Yeah, and how it's established, one-to-one relation, yeah, is basically when you have one, let's say, user, and this user only has his personal settings. Yeah. So yeah, if we have the one-to-many, basically, oh, and in the user, like one-to-one relation, it could be that user have the ID to the personal settings. Yeah. So it just points it to another table. With the one-to-many relationship, yeah, there is like a difference here. So let's say one group of students have multiple students, yeah, and within that, in the student table, we will have just a group ID, yeah, and basically a lot of students could point to one group ID. So that's how we establish the one-to-many relationship, yeah, and many-to-many relationship. It's like the book could have multiple authors, and author could have multiple books, yeah. And that kind of relation is established within the separate table, I mean the third table, when you have only two rows, I mean fields, yeah. The first field will be the book ID, and the second will be an author ID, yeah. And you can specify a pretty big variety of combinations. So for example, book 1 with author 1, book 1 with author 2, and let's say author 1 with book 1, author 2, or I mean author 1 with book 2, yeah. So that kind of variety of combinations could establish the relations between the tables. And to provide you with the way how we are doing that, yeah, is that as you can see, we have a group, yeah, and group could have multiple students, yeah. So for the group table, we have a primary key. It's the unique identifier of a row in the study group table, yeah. And as you can see, in the student table, we have a study group ID, and there is like a foreign key to the study group, yeah. So basically, that's how the relation is established. It's established with an additional field in the student. And basically, with that kind of additional field, we can point a specific user to a specific group, yeah, by storing the ID. And that's how you define the primary key and foreign key. And regarding the primary key and foreign keys, what it is, yeah, the primary key is the unique identifier of a row in the table, yeah, and foreign key is just an field, yeah, that contains the value that is pointing to a primary key of another table, yeah. So it's just used to establish this kind of relations between the tables, yeah. And as you can see, yeah, we will get back. The primary key of the study group is the group ID, but the student also have its own primary key, yeah. But for linking those two tables, we have a foreign key called like study group ID, and its reference to the primary key of a study group. Yeah.
I have two questions about keys.
Yeah.
First one is that, for example, if there is any built-in method with which you can generate some kind of, for example, UUID v4 keys for security. And the second one is about JWT. Yeah, as in homeworks, we use, for example, emails and IDs for tokens, and we actually sign tokens. But for example, when we create these kind of primary keys, what is the best way in large scale apps and in the real projects on to sign these for primary key as an ID or create some other field or for JWT?
Yeah. The best practice is to leave it to the database. So you can also specify some kind of auto incremental, yeah. And it will basically, when you insert each record, yeah, it will automatically create the primary key for that record. So it will like in that case, if we specify auto incremental here, yeah, the group ID, if you insert just, you don't need to even specify the ID here. Yeah, it will be added by default, and it will go from 1 to 2, 3, and incrementally will increase. Yeah. So that's the let's say the best practice here, I guess. Yeah.
Okay, thanks. I will try to use it in Nest.js homeworks, like design the JWT as this.
Okay, yeah. What do you mean by signing the JWT token?
Like, for example, sign ID or email as a token on which JWT will generate a token on.
Okay, yeah, I see.
Yeah, and when you just encrypt token, it will show email or ID instead of token.
Yeah, I see. Okay. So yeah, let's then move to the join. So as I mentioned, the database is not only about one table, it's about the combination of the tables, yeah, and different tables. And there is like a commons, yeah, within which you can basically combine the data within like specific tables. Yeah, you can have like different varieties. Here we listed the 4 of them. Yeah, the left join, the inner join, the right join, and full outer join. So it's just a mechanism of combining 2 or even multiple tables based on some kind of values. Yeah. So we will go through each one, and we will just visually represent how it works. Yeah. So inner join returns rows that have the matching values of both tables. So yeah, as you can see, it's marked with the when we have the crossing. Yeah, and yeah, there's like a typo. It should be table A and table B, but yeah, in some cases you can even do the join to the table that you are joining from. Yeah, so yeah, and basically here, yeah, joining from the left join will basically get everything from the left side, yeah, and also we will have some kind of crossing here. Yeah, the right join is opposite. Yeah, it has the data from the right side and also the crossing here. Yeah, and full outer just provide you with the combination like of all the records. Yeah, from the table. Yeah, and let's move to the syntax. So how you can actually do that is that you write a general query, yeah, to select something from some table, but you would like to add this data to the table, yeah, and it could be established with that inner, left, right, full join, yeah, and basically then you are providing the name of the let's try that kind of thing. Yeah. Oh, yeah, that will be good. Yeah, then you are providing the table name here, yeah. And after that, that kind of part is that basically where you provide the relation, how to establish this kind of connection. In the most cases, yeah, it's established within the ID field. I mean, the primary and foreign keys in both tables, yeah. But in some cases, it could be a different thing. Yeah, you can put not a primary key, for example, do that by some kind of, I don't know, first name, yeah, or last name. Yeah, but as you can see here, we are taking the table A, yeah, then providing some kind of column. Then we are taking the table B and also providing that column. And database automatically will find all the matches. I mean, in the inner join, it will find the crossing. Yeah, in the left join, it will take everything from the table A and the crossing between the table B. Yeah, and the right is opposite. Yeah, and the full. Yeah, it will provide you with the combination. Yeah, of that. Okay, and let me just try how I can clear that. Clear all drawings. Oh, yeah, that will be useful. Okay, so any questions for now?
Nothing actually.
Okay, and let's say from my point, the most let's say the most used joins in the application are the inner join and the left join. Yeah, the right join is rare case. Actually, I saw one right join in the entire application. Yeah, and full outer, I have never used that actually. Yeah, but I guess it could be used for some kind of analytics, yeah, or something like that. Yeah.
I have one like a dummy question, if I
Mhm.
as I get when we are doing left join, we are joining left table to the right set have some connections between them, yeah?
Yeah.
And you mentioned that left is more common, and I think we can do the same on the right. So left table will be on the right side, and we will join on the left table. So I don't get into why developers are using left joins like
Yeah.
this commonly.
Yeah, that's a good question. Yeah, the right join is basically if you implement the SQL query from scratch, yeah, or you are just adjusting something. I mean from scratch, yeah. In most cases, it will be inner join or left join, yeah. But
Okay.
let's imagine a situation that where you have the existing query and you need to add something to it. Yeah, and in that case, you need to add the entire data from the right table. So in that case, you will use the right join. Yeah, you don't want
Okay.
to like rewrite the query to use only left joins instead of right joins. Yeah, so you will use the right join. So it's more about extending the existing query.
Yeah, okay.
I'm sorry, I have a question about self-join. You didn't mention it. Is it have some usage in real-world projects
Yeah.
here?
Yeah, so the simple example here is we have a user table, yeah, and we invented managers, yeah, and general user could be a manager of another user, yeah, and we've added, let's say, new column called manager ID, and inside that column manager ID, we're basically storing the user ID, yeah, and this kind of we can do the self join, so it will be select from user, inner join user on user dot, then it will be user ID, user dot manager ID. So that we will just to the users, all users, we will add their managers to the table. Yeah. So it's a use case. It's not a rare use case, but yeah, it could be in your application.
Thank you.
Okay, I guess we can take a break for about 5 minutes. Yeah, and after that we will proceed. Okay, so that's all about the joins, yeah, and we will move to the next thing, table-like thing in the database. Yeah, we called it the view. Yeah. So what is the view? View is actual virtual table or abstract table representation. But under the hood, it actually contains some kind of specific query. Yeah. So as you can see, this is how we can create a view. Yeah. So we just yeah. Let me grab my cool tool. We have a command called create view. Yeah. Then we specify the name of view, and after that, there is like a block where you put the query. Yeah, it could be in that case, it's pretty simple. Yeah, we're just getting from the table, but it could be a big query with a lot of joins, a lot of where statements. I mean, that's filtering and some kind of stuff. Yeah, and why do we need that? Yeah, yeah, I need to clear everything. Yeah, and why do we need that? Yeah, we need that like for the security, query simplicity, and consistency. Yeah, security. How it actually works, how it's like secure. Yeah, let's say you don't want to provide the access to the database to a specific user. Yeah, you can create some kind of general tables. I don't know, maybe analytics. That represent the analytics of the database, and you can grant the privileges only to that view. Yeah, the view you cannot modify the view. Yeah, it's there's some kind of also security you cannot modify because it's just a query that is triggered when you are opening the view. Yeah. Query simplicity, yeah, because it's the representation of the some kind of query. Yeah, you can work with the table. It's provide you the good visualization, and also you can also do some kind of operations within the view. Yeah, and I mean the columns that exist in the view. And consistency. So everything is in the one view, and you do not have access to other like things. Yeah, but there is like disadvantages. The disadvantage is the performance because you need to execute that kind of query every time when you are accessing the view. Yeah, anyway, under the hood, it will be the SQL query. So that could lead to some kind of performance issues. Yeah. And it's not that easy to, let's say, in some cases, you need to modify the view. I mean, the query inside the view. So it's put some kind of a little bit complexity here when we are trying to optimize the query. Yeah. And update restrictions. Yeah, as I mentioned, you cannot modify the data through the view. Yeah, it's some kind of security, but you are missing some kind of functionality by like updating the data in the view. Yeah. Okay, and we will also talk about such thing, how the like a database normalization. So the database normalization is a organization method, yeah, that prevents data redundancy and prevents some kind of anomalies. Yeah, by anomalies I mean like something, let's say the duplicate of the data, yeah, or some kind of strange way of storing the data, yeah. So within that kind of steps, yeah, that I will show you, we can avoid such things. So there are a lot of like let's say forms, normal forms, yeah. We will take a look at a few of them. I mean, in particularly 3 of them, the first, the second, and the third. Yeah, we will see how you can actually modify the structure of your data and tables. Yeah, and which rules you should follow. Yeah, so let's then take a look at the first normal form. Yeah, I will draw. The first normal form says that all attributes should be simple. Yeah, as you can see, we have a table. Yeah, some kind of table. We don't have a specific name, but we have 3 records. Yeah, and in the first record, as you can see, we have the movies rented. Yeah, and there are multiple records here. 1 and the second one. Yeah, the same for the second row. 1 here and another here. Yeah. So the first form tells you to make all the records like simple with the simple value. In our case, it will be only 1 value per row. Yeah. So we split the first row, I mean the Janet Jones, in 2 records. Yeah. As you can see now, we have the data duplication, but each row has its own only one value. Yeah. The same story with the Robert field. Yeah, we split it like the second row, the Robert field here, in 2. Yeah, and you can see, yeah, we have now 2 records instead of 1. Yeah, and in total, if we do all the manipulations, we have, instead of 3 records, we have 5 records. Yeah. So that's like the first normal form. Then we will move to the second normal form. The second normal form tells you should follow the first normal form, and like, let's say, records should not depend on anything other than the primary key of the table. So we will take a look at the example here. Yeah, as you can see, we have record 1 and 2. Yeah, and after that kind of splitting, now we have like movies rented. Yeah, and movies, the value of this column is dependent on let's say the Janet Jones and some kind of address. Yeah, and even the salutation, yeah, are the same. So that's what we would like to let's say avoid here, to make all records be dependent on some kind of primary key. Yeah, and how we can approach that is basically we get all these kind of duplicated data, yeah, that basically are related to the let's say some kind of person, yeah, and we move them to a new table, yeah, and yeah, we provide some kind of unique ID. I mean the primary key. Here is the primary key, yeah. And for each row, we specify this like unique ID. Yeah. So we took the Janet Jones first street plot number 4 and Mrs. Yeah, and we put that as a single row. The same story with that combination, Robert Field and 3rd Street. Yeah, and also the third combination of Robert Field and Avenue. Yeah. So we moved that to a new table, provided each combination of full name and physical address with some kind of specific ID. And then we simplify the existing one by removing all this unnecessary data and just providing the ID. Yeah. So instead of Janet Jones first name and that, we are just have a pointer, and it will be a foreign key. Yeah. Foreign key. Yeah, to that specific table. Yeah. Then the same like that, pointer. Yeah. So that's how we make each row to be dependent on the primary key. Yeah. Okay, so that's like the second form. And the third form should extend the second form. And the additional requirement for the third form. Okay, let me clear. Yeah. Yeah, and the requirement for the third form is that it requires moving all non-prime attribute fields, yeah, whose connects may be related to several table records to separate tables. So yeah, a lot of words, complicated words, but we will take a look at that. Yep. So as you can see, after all other our optimizations, we've created a new table. Yeah, but as we can see here, we have some duplication. Yep. That's not actually a good thing. Yeah, and we would like to somehow move that to a separate table. Instead of specific value, yeah, we would like to have the primary key. Yeah. And what we actually did is that we created a new table. I will point here, yeah. And now it's the, let's say, the salutation table, yeah. And we've provided the primary key for each unique value, yeah. And basically, for that kind of things, we are providing some kind of unique ID, yeah. And also for the fields, yeah, as you mentioned, as you remember, we did that kind of thing. So after following 3 normal forms, yeah, instead of one complex table, we have 3 tables that are just pointed to each other. Yeah, the salutation is pointed to that kind of column. The member here, membership, is pointed to that table. Yeah, so that's how we establish the data. And why we need to do that? Because when we split the data in that kind of way, yeah, it will be much easier to write the code to establish the joins and some similar things like we have in the database. Yeah. But let me remove that. Yeah, but that is not the silver bullet. Yeah. So you should be careful with the database normalization because it's not always a good thing. In some cases, you actually need to denormalize data. The simple case, let's say inside your application, yeah, you have a table, and to get additional data that you need for some, I don't know, business case in your application, you need to join 10 tables. Yeah, and that's like, let's say, not a rare case. It could be really, let's say, general case in big applications. Yeah, and to establish this kind of to get only, for example, at least one field, you need to establish and join 10 tables, yeah? And the query could become really big, yeah, and heavy, and so the execution could be, let's say, 5 seconds instead of a half second, yeah? And to do that, you would like to do some kind of denormalizations. I mean, to duplicate the data. So instead of following that kind of general thing, you can just create a new column in the first table and just, I mean, duplicate the data there. Yeah. So in that case, you don't need to join everything. You just have, like, let's say, the duplicate of the data. Yeah. And as I remember in one of last lectures, was the thing that's about the likes. Yeah. And I said that imagine a situation where the post has 1 million likes. and the query could be pretty heavy to calculate the like the count of the likes, yeah. And in that case, you can also try to do the denormalization, yeah. I don't want to point you to the specific let's say way how you can handle that, but you can think of how you can handle that to avoid calculating all the likes when you are requesting just a single post. Okay, any questions for now?
So is there some kind of, I don't know, software that will help us to structure our databases? Like we can set, no?
No, there is like no such tool. Yeah. It's just you will do that by yourself. Yeah. And all developers are doing that by themselves. Yeah. Maybe there is some kind of tool, but that's not that popular. That's yeah, I can hear, I'm aware of that tool. Yeah. And yeah, basically all our developers are like structuring them by themselves. Yeah.
So manually, I think.
Yeah, manually. Yeah. Okay, so let's then move to the next thing. And as I mentioned, partially like mentioned the query optimization. Yeah, and there is like a specific structure, data structure in the database that could increase like the performance of some queries. Yeah, and this structure is called the indexes. So the index is the as I mentioned, the structure that database creates under the hood. Yeah, and that kind of thing helps you to query data faster. Yeah, so how we can create the index? Basically, we put the create index, provide the index name, on which table we would like to put the index, and then we provide the some kind of the columns. Yeah, it could be only one column. So let's say we would like to increase the performance for the first name. Yeah, but it could also be for the combination of the columns. So let's say the first name and last name. Yeah, so you can specify the second column here. Yeah, and yeah, so that's how you define the indexes. And yeah, what kind of indexes could exist? Yeah, it could be the binary tree. Yeah, so as I mentioned, under the hood, the database will create that kind of structure. Yeah, and will handle this kind of structure by itself. Yeah. So when you insert something, it will automatically insert that row in that kind of structure. And let's say when you're doing the search, yeah, it will use this structure to speed up the search. Yeah. Also, it could be the hash. Yeah. So there are different variants of the indexes that you can introduce here. Yeah, but the main thing why we use the indexes is the major advantage is to improve the performance of the query, and I mean searching the specific records, filtering them out. Yeah, but you should be also careful with indexes. Yeah, there might be a question: why not to put index to each field? Yeah, everything will be super fast. Yeah, it will be fast, but not for the insert, update, and delete. Yeah, as I mentioned, under the hood, yeah, the database create that kind of structure, and on each insert, on each modification of the data, it needs to make changes also inside that structure. Yeah, and even in some cases, it needs to rebalance it, restructure. Yeah, I mean to move one data to another. Yeah, so it might take some time. Yeah, and in some cases, it could be even noticeable. Yeah, on the insert, update, or delete operations. And also, this kind of additional structure takes some time and space on the disk. Yeah, so you can also face some kind of space issues. Yeah, but the major disadvantage here is the slowness of the modification operations. Yeah. So that's how you can optimize your queries. Yeah. But there is like also the process, the general process in the database. It's called the migration. So what is the migration? Migration is just a script that is somehow modifies the data in the database. I mean, let's say not modifies, it's doing something with the data in the database or even the tables. Yeah. So what kind of things it could be? The data transfer, yeah, let's say we would like to move data from one table to another, or to from one resource to our database, yeah. To restore data from the backup. I mean that we did some kind of backup during the release, yeah, and we would like to store that data in the application. So we can also establish that within the migration. Change the data, the table structure. Yeah, if we would like to add some kind of new column or change the column, it should be done within the migration. And fixing the existing data. Yeah, like if there is some kind of bug in our system, it's put the incorrect value inside the database, yeah, for some reason. And after noticing the problem, we fix the problem, but we additionally need to fix the data, the incorrect data that we have. Yeah, and with that kind of process, you should also run in the migration. Yeah.
We always save migration logs, right?
We always save migration logs. What do you mean by migration logs?
Yeah, I have seen that, for example, some ORMs are creating migration logs like with dates and migration datas and this thing.
We should always do that, because without that thing, we don't know if we need to run that migration or not. So the ORM system basically provides you with that kind of possibility. Yeah, and when the migration is executed on the database, the ORM, basically there is like a specific table responsible for that. As I remember, for the SQLize is SQLize meta, where you have the name of the migration that you executed. And on the, let's say, or on the start of the application, you have like to run all the migrations, and the ORM checks. It gets all the migrations from a specific folder, checks all names, and matching that with the data that exists in the table. Yeah, and that's how the ORM understands if it's need to execute the script that you wrote, or it was already executed. Yeah, so it's always stores the data there.
No, okay, thanks very much.
Sure.
And how the migrations differ from like simple inserts and updates to change the data, for instance?
Yeah, and we will discuss that in a second, but to answering your question is that provide you with the documentation. When someone execute native update, you do not have any like, let's say, log or input who did that, when that happened, and what was the logic. Yeah, and when you are running the migration, it's basically the script. It could be written in JavaScript. Yeah, and in some kind of folder inside your application, there will be a record with the specific name, and then you can open it and then see, oh, that was the logic, that what actually happened. Yeah, and that provides you with some kind of context. Yeah, rather than someone executed something. Yeah, and we are not aware of that action.
Okay, thank you.
Yeah, sure. And to the advices and basically use cases. Yeah. So migration provides you with the documentation of what's happened, when happened, and who did that. I mean, we can also always check who wrote that code. Yeah. We can see the flow of the execution, and basically in the database we can see when that happened. So if something was wrong within the migration, we are not like asking some other people who did that, and we are not aware of that kind of changes. It was something incorrect. We need to understand what was incorrect. We just get the migration from the folder and follows the logic that was written there. The advices here is to check the migration results on different amount of data. So we discussed the benefit of the migrations. But we also would like to provide you with some kind of suggestions. Is that migration is could vary, depends on the case, and you should not limit to a specific, like, let's say, local data. When you would like to deploy the migration to the production, you definitely need to check that on some kind of similar data to the production. We can create in our project, we create a copy of the prod database and basically work with that database to cover all the use cases and to make sure that migration works fine, not only for the local data because it could be limited, but also for the production like data. You should use the SQL transactions, because if you the migration is just a script, as I mentioned, and if something is wrong with that script, we would like to roll everything back. So try to use the transactions. It could wrap the entire migration, or for example, it could do that in chunks. If we insert really a lot of data, we don't want to have the transaction to handle, I don't know, 500,000 of inserts. We would like to do that in chunks. Because if we do that in a single transaction, it will basically we could lead to some kind of errors. So we can do that in chunks, but wrapping each chunk with the SQL transaction. And also you should add the logs to the transaction to actually see what happened. What was the state of the row that you are trying to update? What was the actual data that you are trying to update? So it's really useful to see in case of some kind of errors. You can easily understand on which step the error happened. Well, let's say you have multiple updates, and after the execution of a migration, it just errors out and you don't know what was the use case. By adding some kind of additional logs there to provide you with the context, you will see on which state the error happened. So that's like the advices for the migrations. Any questions? Okay.
No.
Okay. Let's move to the as I mentioned, the attacks that could be that could be executed in terms of the SQL database. So the SQL injections is the attack that uses security vulnerability on the SQL query layer. So here is we have two examples. Yeah, the first one and the second one. The first one basically gets the records from the user by some kind of username. Yeah, as you can see here, we have a statement that filters all the users that have like a specific username. Yeah, but there is like a way using the vulnerability that you have. Yeah, you can move from that SQL query to that one. Yeah, and you are just maybe could be surprised how that could happen. Yeah, and we will talk about in a second. Yeah, so how it's actually executed from the query perspective. Yeah, let's say you implemented the API and the API. Yeah, the API has the user's namespace, and you provide some kind of parameter, yeah, called username, where you can specify the string, and you expect that, like here, it could be, for example, John, yeah, or David, something like that, yeah. But the attacker put some kind of different thing here, yeah, and that's how he can trick your code. And basically, after that kind of things, in the execution we have this query, yeah, and really surprised how that's happened, yeah. And the way why that happened, yeah, is that, as you can see, there's like a piece of code, yeah, and as you can see here, we have a direct insert into a string, yeah. And basically, if when we are doing that kind of direct insert, yeah, it's puts that kind of thing that we provided here, yeah, and it's just ignores that additional part. I mean, the part that will be ignored is this, yeah, this one, yeah. Yeah, because here we will add that kind of additional thing. So that's how the user actually could get all the users from your table. As you can see here at the result, we got all the users. It gets the data for the super admin, some kind of John, and additional like admin, yeah. And how to prevent such things in your application. So first, you should check the incoming data. Yeah. So basically, the ORM, there is like a tool. Like there is an internal checks to verify that if someone provide the SQL query, it will be inserted not directly to the query, but it will wrapped in the some kind of brackets. Yeah, and that's how the SQL query, the ORM systems handle that. Yeah, but you can write your own checks. Yeah, to make sure that what was provided in the parameters is not a part of SQL query. Yeah. So the second thing how we could prevent that is to set up the access, because we've like talked about the pretty general case where you just modify the select to the select, yeah. But it could be the attacker could modify the select to the update, yeah. So he just provides some kind of query that's provide the first part will be the end of the select statement, yeah, and the second part will be, let's say, drop database, yeah. So within providing the access, yeah, so if the query is executed, it should be executed in the select mode, and if there is some if the update is appeared within the specific query, yeah, you should ignore it, yeah. So that's how you can set up the access. Yeah? encrypt sensitive data. Yeah, if the user gets the data, as you can see in the previous example, we get in that case the first name and last name, but let's say it could be the password. Yeah, and in that case we would like to encrypt the password so the attacker will not get any sensitive data. Yeah, it will have the emails and last name and some kind of additional things, but it will not get some kind of data of your bank account or some kind of secure data. Yeah, so you should always encrypt sensitive data. And also set up database error logging. So in case if some kind of error appear, yeah, to the tool to notify you. Yeah, basically you will be notified if something is strange is happening. Yeah, so that's how you can also do such things and prevent such things. Yeah. So any questions? Okay, no questions. Then let's move to the ORM. Yeah. What is the ORM? Yeah, and what kind of ORMs we can use? Basically, ORM is an abstract layer between your, let's say, server and the database. It's the tool that provides you with some kind of API, yeah, that you can use to make your life easier, yeah, and such things. It's like SQLize, TypeORM, and Prisma, yeah. So as some of you might notice that in the Google chat we provided we have mixed feelings about Prisma because even when I was talking with my colleagues, yeah, the major part of them were not so let's say fan of this ORM, yeah. So in the most projects we use SQLize, TypeORM, or some simple things for data structuring like Knex or yes, some other things. Yeah, but the most modern are SQLize and TypeORM. Yeah. And what benefits provides ORM provides us with? Yeah. It speeds up the implementation and the development, and also simplifies it. Yeah, so you don't need to work with the database. You can work with the database as a code. Poor performance, Prisma. Yeah, not sure about that. Yeah, but it could be the case. Yeah, and also the ORM. It's like a mechanism of preventing the SQL injections. As I mentioned, there is like a way how you can write the code to avoid these kind of injections. Yeah, so it applies some kind of additional validations under your code. Yeah, simplifies database switching. Yeah, it's a really rare case where you would like to change the database from, let's say, MySQL to Postgres. Yeah, but it could be. Yeah, it's provide you with some kind of abstraction under the database, so you can by changing, let's say, several things, several lines of code, you can change from the MySQL to PostgreSQL. Yeah, and it's provide you with the built-in mechanism of migrations. Yeah, so automatically handle them, creates the files, runs the files with the specific commands. Yeah, so easy to work with the migrations. And what kind of disadvantages we could have? Yeah, the disadvantages are the complex queries. Yeah, that you structure based with the ORM API, yeah, could lead to performance issues. The real use case from my side, there was a big query that was written using the ORM API, and it took 15 seconds to execute. And I optimized that query. So after rewriting the query to a native SQL, yeah, it was running for about let's say less than 1 second. Yeah. But yeah, after executing a query, I have to map values to do that kind of grouping, yeah, by myself, yeah. But you should be aware that at some point the ORM system could, for example, instead of general join, yeah, it could use a subselect. As a subselect is that you can select something inside the select. Yeah, I don't want to dive into that topic, but you should be aware that the ORM could put some kind of additional not necessary things to the query, yeah, and it could lead to the performance issues. And the second thing that is also a significant disadvantage, that you lose understanding of queries, yeah. If you always use the ORM, yeah, you don't understand what is happening under the hood. You're basically interacting with the database within some kind of code or API, yeah. You lose your skill to write the native SQL queries, yeah. So that's also the really important part, yeah. And yeah, so you should not also forget how to use the native SQL. Okay, and how you can install and start work with the ORM, yeah. You can just install the package, yeah. You can install the native SQLize, or you can install the Nest.js extension, yeah. And also the same thing for the TypeORM, yeah. You can install the Nest.js, like let's say package, or just the TypeORM. Yeah, in my application, we are using just the SQLize, not the Nest.js SQLize. Yeah, and also you should install the packages that are related to the database, yeah, that you are using. So the Postgres, MySQL, SQLite, or for example MS SQL. Yeah. And so how to, I will provide you with the examples. Yeah, but before moving to the example, I see the question, can we use Drizzle? What is the Drizzle? Is that some kind of ORM? Oh, no, we will force you to write in the SQLize or TypeORM, yeah, because it's easier to us to verify your homeworks. Yeah, we are aware of the API. In case of some kind of challenges that you face, we could easily support you rather than, you know, diving into the a new technology. Yeah. Okay. Yeah, and that's how you can specify the connection to the database. Yeah, as you can see here, we are creating a instance of the SQLize. Then we are providing the dialect. Yeah, and that's what I mentioned. Yeah, by changing that from MySQL to the Postgres, you can easily change the database. Of course, you need to change the host port user. Yeah, but the change is pretty quick. Yeah. Also we have parameters like host, port, the user, username, password, specifically the database to which you should connect. Also, you can specify the logging. Yeah. So in that case, it's not enabled. Yeah, but you can also put here the console log. Yeah, and when some kind of query is executed under the hood, yeah, I mean under the ORM, it will be displayed in the console. Yeah. And some kind of additional parameters here. Yeah, so that's how you establish the configuration. Yeah. And also, as I mentioned, each table has its own representation in the ORM, and it's called the model. Yeah. And for each table, you can specify the model and work with the model rather than writing queries like, let's say, select from user, then just providing, the username and then getting some kind of data. You can work with the models. Yeah, and that's how you can specify it. Yeah, you are just creating a class and providing the data for each column. Yeah, as you can see here, the username ID is the primary key, auto-incremented. It's the big integer. Yeah, and also, like, as you can see, we even can specify the foreign keys. Yeah, the user ID is, oh yeah, let me use my super pen. The user ID is a foreign key to another table, but in case of ORM, we are using the user model. Yeah, so that's how you can establish that. And also, as you can see, you can specify some kind of additional parameters, like the user ID is allow null true. So basically, you can put also null value in the user ID field. Yeah, so that's how you specify the let's say model, but how to connect it to the ORM. Yeah, that's how you can do that. So basically, as you can see, there is like a Nest.js style code. Yeah. So we've created some kind of provider. We've specified the unique identifier for that provider. And inside the use factory, we can specify the code, yeah, for establishing. So create Sequelize here, create the connection, yeah, between the database. And then we can add models by that specific command, add models. And as you can see, there is like an array here, and we're just providing all the models there. Yeah, and then just return the Sequelize. Yeah. And how we can use this kind of thing. Yeah. So basically, we were mentioning the 3-layer architecture. Yeah. And there is a specific, let's say, layer called the repository or data access layer, I mean DAL. Yeah. So there is like a class. Then you insert the Sequelize there, yeah, and you can basically use the Sequelize like here, yeah. So here we're just executing some kind of query, yeah, as you can see here. And this like thing, yeah, is the way how you avoid the SQL injections, yeah. So you're just providing 2 dots here, the name of the parameter, and where we provide the value, we provide value in the replacement here, yeah. And the Sequelize under the hood automatically will insert the username ID here, avoiding the SQL injections. Yeah. So that's the way how you can work with the Sequelize, but you can also insert the modules here, yeah, models here, and work with the models rather than writing a real, let's say, SQL. Yeah. So there are 2 variants. Yeah, writing the SQL queries, native SQL queries, or working with the models. Yeah. So also we will, yeah, sure. Oh, yeah. Okay, and we will provide you with some kind of useful links, yeah, to the packages, where you can take a look at the package in the NPM, to take a look at the API, also to learn the SQL in more details. To, you know, if I was diving into the details for each command, yeah, the lecture will be really big, yeah. So yeah, and also we will provide you with some kind of additional things like code wars. Yeah, you can do some general, let's say, tasks. Yeah, to like have experience with working with the SQL. So inside that kind of specific resource, there will be a task that you need to implement, and you will just write the SQL query, and it will verify if the SQL query is correct, yeah, that you provided the correct SQL query, and after completing the this kind of task, you will also see how other people were able to deal with that kind of problem. Yeah, so it's really useful thing to do. Yeah, and yeah, that's it. Yeah, so do you have any questions?
So a question about RAMs. So the main advantage is we can translate our program from one database type to another, like from MySQL to Postgres. So what will happen to handwritten SQL queries inside our code? So we need to change them or some Ultimate translator?
Yeah, so that's the thing. Yeah, if you write the native queries, that could use some kind of tools that specifically database provides. Let's say the PostgreSQL has its own tools to work with the, let's say, data time. Yeah, and they are not basically supported in the MySQL, or they are supported but within the other commands. Yeah, you have to rewrite all the SQL queries that are depends on that kind of stuff. But if you are using the models, yeah, then you don't need to rewrite it. Yeah.
Got it. Thank you.
Mhm.
For a database, are we going to use database on a local machine or some external resource?
You are going to use the database on your local machine. Yeah.
Thank you.
Mhm.
May I ask, please, what is more common using in your company, for example, using raw SQL queries or models?
It's the combination. If the if the query is simple, yeah, to just get something from a table with some kind of condition, we are using the models. If the query requires some complex things like joins, yeah, or like we would like to make sure that it's the performance is good, yeah, then we write queries in the native SQL.
Please,
So
next question. Please, I'm sorry, next question. Which database your company is preferring? Do you have preferred database, for example, PostgreSQL or MySQL, or
No,
it differs from project to project?
Yeah, it depends on the project. So in some projects we have the MySQL, Postgres, some of them using their, let's say, the MS SQL. Yeah, even the SAP related projects has their own database called S4HANA. In my project, we are using the Redis. It's NoSQL database. We are using the MySQL database, and also we have a graph database, called the EringoDB. So it depends on the project. There is no like specific requirement here. Okay, I heard that someone was
Thank-
trying to ask, the question. Yeah.
yeah, so in this case, models are just like Mongoose models, right? Mongoose schemas.
Yes. Yeah.
Okay.
Because the Mongoose is the ODM. It's object document, as I remember, something
Yeah.
like that. Yeah. So, but
Because it's NoSQL, right?
yeah,
Mhm.
because of that.
Sure.
But
Thank-
the same pattern. And
Mhm.
can we use Docker? Yes, you can. Yeah, it will be great if you can specify the Docker files. Yeah, it will be really great. Yeah. Okay. Okay, so let then stop with the lecture and I will show you the homework. Oh, what is this? Okay, something strange. Oops. Okay. I get it. It's not the it's the Zoom related. I was surprised. Yeah, so what will be the homework for you? Yeah, the stack will be the MySQL and SQLize or TypeORM. Yeah, and basically change that. Then basically you will need to adapt your previous homework. Now instead of database, instead of in memory, you are going to use the database. Yeah. You should also add the migrations to create all tables and relations to actually like establish the database and all the relations. Yeah. Also, you will need to write the migration to fill the database with some kind of dump data. Yeah. Also, you should create the models for each entity of the database. Yeah. And apply pagination, sorting, and filtering functionality to each request that requires returns multiple records. So as you remember, we've added some things like to get posts of another user. Yeah, so you should apply these things to the endpoints, and also like additional requirement that we mentioned here. So yeah, that's everything that's will be in your next homework. Yeah. Okay, then I think that's it.
Question, please.